Okay, so there's lots of ways to approach this question. I think you should probably try some numbers as well, but there's some interesting things to be even said about that. But here you could just, so you don't know exactly where on the locker it is, okay? So, it could be like, for example, so this thing could be just position A, right? This thing here is position, it's two more. It's A plus two, right? But it's like one row down, isn't it? So it's plus n, yeah? And then this one, it's A minus 3 plus n, yeah? Okay, 2n, yeah, good. Okay, plus 2n. And then so the condition is Kate's number divides each of their locker numbers. Okay, obviously 1 divides everything, but Kate's can't be 1 because Kate's sitting in between two people here, from 1 to 30. Okay? Alright, so okay, so then there's this kind of nice little fact, obviously, like you might have used a few times or may have not seen, I don't know, but like if a number divides two numbers, like if a number divides x and y, then it divides any combination of x and y. Okay? So you can manipulate the expression until you get rid of all the things you don't want. Okay? So for example, um, what can we do? We can use this a to get rid of the a's in the other expression, right?
Yeah.
And then we can times this one by 2 and subtract this one from that, and you get case number divides 7. Does that make sense? You know what I'm talking about?
Yeah.
So if case number is k, right? K divides a, k divides this, k divides that, right?
Yeah.
So you can subtract a from all of them. So k divides 2 plus n, and k divides minus 3 plus 2n, right? And you can times this by 2 and k still divides it, and you can subtract this from that and k still divides it. So k divides 7, right? So then k has to be 7. Okay. What's kind of interesting about this problem is not all n actually work for this problem.
It's really scuffly written.
So you might have an exercise like which n actually works. Okay, or how did Charlotte do it?
Okay, so basically, if you have a grid of numbers,
Yeah.
and say like you take the multiples of any number, and you color them in, you're gonna have diagonals, right? And you can prove that happens because it's like mod n. But basically, you have diagonals. So all you have to do is you have the diagonal here. Say put an x there, and that's 1, 2, 3, 4, 5, 6, 7.
Wait, can you explain that a bit slower? So, what are you saying
So
about
if you have
diagonals?
like a grid of numbers, and
Like
then
a
you take
lattice?
yeah,
Okay.
yeah, and then you take like the multiples of any number, and like it's going to form like diagonals, right? And you can prove that happens. But we can just say that
What do you mean
happens.
when you say take the multiples of any number?
Any number, like if you like want to have like a lattice of numbers and you color in all the multiples of 3, you have a diagonal. You have like a bunch of
So
diagonals.
how are the numbers labeled? Are they labeled like this?
1, 2, 3, blah blah. Yeah, like that. Like if you have like
Oh, okay. It's like kind of like modular arithmetic.
yeah. So if you just so it has to be a diagonal. So that has to be one there. Even if it doesn't reach that, it still works. And so that's 7. So that has to be.
Huh.
Oh yeah. Wait, don't you just get n has to be 517?
What did you get?
Because what? You have n plus 2, 7 divides n plus 2, therefore n is 517. And it just holds for n.
N is 517.
I have to say this question is
So
terribly
N
written.
could be. Oh, so N can be 5, but it can be like 12. Yeah.
Yeah. Yeah.
So let's see, does that work? If N is 12,
What? 7. So,
yeah. So maybe this is like position 5 out of 12, or does it actually depend on? So A This is a plus 2 plus 12.
Yeah, so that's
A
21.
minus 3 plus 24.
21 plus 28, so you get 7.
That's a minus 21. This is a plus 14.
Yeah.
So what would a be?
7.
7.
Can we talk about the wording
Yeah.
of this problem? It's
Oh, so a has to be a multiple of 7, yeah. Alright. That's it.
a genuine. Who do they get